All right, so on page 7, we had done number 6, part A. We had not yet done part B. So let's go and look at that one. Again, there's 2 criteria that have to be met in order for 2 shapes to be similar. They have to have corresponding congruent angles, and the sides have to be proportional. So the angles seem to be the easiest thing for us to check on part B, just like they were on part A. What do you notice about all of the angles? They're all right angles. So can we say that corresponding angles are congruent? Yes. All the angles are the same size, so corresponding angles would have to be congruent. All right, so now we want to know, are the sides proportional? Squeeze it in there. Are the sides proportional? Okay. Do you guys remember how we match up the sides? We put the biggest side on one figure with the biggest side on the other figure. Yes. Okay, so the biggest side on my left-hand triangle is 32. What's the biggest side on my right-hand rectangle? 8. So I'd have to put 32 and 8 together in some kind of fraction. Remember, I want to see, are these proportional? Does it matter whether I put the 32 or the 8 on top? Nope, does not matter. I just have to stay consistent for the next one. So let's put 32 on the top and 8 on the bottom. And then we're going to match up the smaller sides, 16 and 3. So I would have 16 in my numerator and 3 in my denominator. And now we're going to divide those. What is 32 divided by 8? 4. And 16 divided by 3? 5.5, just like 5.5 at the end. 5.3 repeating. Biggest idea here, though, is what do you notice about those two numbers? Are these sides proportional? No. Proportional means the fractions come out to be exactly the same. These are not equal, so we would say the sides are not proportional. So are the rectangles similar? No. Rectangles are not similar. Nicely done. Let's do another one like this. Let's look at number 6, part C. First thing I need to know on number 6, part C is, are the corresponding angles congruent? Do I have an angle that is congruent to N on the other triangle? Yes, angle R. Do I have an angle that is congruent to Q on the other triangle? Yes, S. And so, if you guys remember back to first semester, by the third angles theorem, that means that angle P and angle T would have to be congruent. Thank you. So are my corresponding angles congruent? Yes. Corresponding angles are congruent. Beautiful. Okay, so now are the sides proportional? We have all three sides on both of these triangles. We have to make sure that all three pairs of corresponding sides are proportional. So the first thing we're going to do is match the smallest with the smallest, or we could match the biggest with the biggest first. You just want to make sure that you put the biggest ones together, the smallest ones together, and the ones in the middle together. So what is our smallest side on this triangle? 11.5. And what's the smallest side on the other triangle? 9.2. Let's make a fraction with 11.5 and 9.2. I can't just put an equal sign because I don't know that it's equal. Equal sign with a question mark over the top because I need to know, is this equal? That's what I'm asking right here. What's the next smallest side on this triangle? 12.5. And the next smallest side here? 10. So we're going to do 12.5 over 10. We could flip it around the other way if we wanted to, but we would have to change our first fraction as well. You got to stay consistent. Whichever one is on top is all coming from the same triangle. All right, and so then that means what other two sides would have to match up? 15 and 12. Which one should go on top? 15. 15 over 12. And now I need to do 3 division problems on my calculator to see what these come out to. What do you get if you do 11.5 divided by 9.2? What'd you say? 105. That's okay. 1.25. All right, so I got a 1.25 there. 12.5 divided by 10? 1.25. So that one's equal. Is that enough for me to say that the sides are proportional? No, you got to check the third one also. What is 15 divided by 12? 1.25 again. So are my sides proportional? Yes. What does that mean about my figures? Yes, the triangles are similar. Because the triangles are similar, what do I still need to find? Yes, we need to find the scale factor for the reduction and the enlargement. Remember yesterday when we did number 6 part A, and I told you after we did those fractions, we had found one of them already. This 1.25, that's a scale factor. Would that be the scale factor for the enlargement or the reduction? Enlargement. If it's for a reduction, what does it have to start with? Has to be a 0 point something if it's a reduction. If it's anything other than a 0 point something, it's going to be an enlargement. So our scale factor for the enlargement is 1.25. All right, I'm going to test some people here, see if we know this. Does anybody happen to know what 1.25 would be as a fraction? It's okay if you don't. 5 over 4, very good. 5 over 4 would be 1.25 as a fraction. Scale factor for the reduction. One of these fractions from up here, I want to take and flip over. I could do it to any of them. I'm going to get the same answer from all of them. But I want to take one of them and flip it over. You guys okay if we flip over the 15 over 12? All right, so for the reduction, we would have 12 over 15. Can I reduce that at all? Is there anything that goes into 12 and 15 at the same time? 3 goes into both. So if I divide them both by 3, I would get 4 over 5, or what would that be as a decimal? 0.8. Can you give your answer as a decimal? Can you give your answer as a fraction? Yes. Do you have to give it both ways? No. Pick one. You only have to give it to me one way. We're going to skip part D because it's a lot like part B, and we just did part B. So we're going to flip the page over and look at number 7 now. It says triangle ABC has been dilated. So is ABC the original or the new if it has been dilated? That is our original. We took this one and did something to it. All right, so here's our original. To create triangle DEF, so triangle DEF would be my new one. And then it says find the scale factor and the values of sides. All right, so scale factor first. Scale factor is new over original. When you are looking at these triangles, 2 of the sides that are shown are corresponding. Which 2 sides would have to be our corresponding sides? The 20 and the 8. Side DE right here, and side AB right here. So new over original, I would have 20 over 8. And what does that simplify to give us? $2.5. 5 over 2 or 2.5? Right, so there's the first thing that they asked me to do. They asked me to find the scale factor. And then they asked me to find the value of the sides. So there are 2 missing sides here. We've got this side, side BC on my original triangle. And we have this side, side DF on my new triangle. You guys okay if we find DF first? All right. So scale factor equals new over original. We know our scale factor is 5 over 2 or 2.5. It does not matter whether you use the fraction or the decimal, but that's what we're going to put in the place of scale factor here. Is equal to, we said we're finding DF first, right? Is that on my new triangle or my original? New. DF, that's on my new triangle. You did not. What side would that correspond to? AC. So what should go in my denominator then? 10. We saw a problem kind of like this the other day, where we had a fraction and we wanted to get rid of the fraction because what we were looking for was on the top. What operation undoes fractions? Multiplication. So we're going to multiply by what part of the fraction? By the denominator. So we're going to multiply by 10. And if you do it to one side, have to do it to the other side. So the 10s cancel out over on the right. The denominator goes away. And we have 10 times 2.5, which is 25. So 25 is equal to DF. Nicely done. All right, we have one more side left to find, and that's BC. Scale factor equals new over original. Scale factor stays the same. We're going to put 2.5 or 5 over 2 in here. Equals. Do I have the new measurement to substitute in? Yes. This side right here. That's coming from my new triangle, and it's how big? 30. 30 over. That corresponds to what? BC, and I don't know how big BC is, so BC just goes down on the bottom as BC. Just like the problem up above, I have a fraction. And we're going to approach this the exact same way. What part of the fraction do you multiply by? By the denominator. In the denominator is BC. That's okay. We're going to multiply by this. It's a variable. If you do it to one side, you do it to the other side. So we multiply both sides by BC. It cancels out in the denominator on the right. And so what I have now on the left is 2.5 BC. And I'm going to put BC inside parentheses so that I remember that it's one thing. That's one side. Equals 30. What operation is happening right here in between the 2.5 and the BC? Multiplication. Well, what can I use to undo multiplication? Division. What would I divide by? What is it that I want to cancel? The 2.5. I want the 2.5 to go away so that I have BC all by itself. So we're going to divide both sides by 2.5. And that gives me BC equals, what is 30 divided by 2.5? 12. Perfect. All right, let's fill in our answer blanks here. The scale factor was 5 over 2, or you could write that as 2.5. BC was 12, and DF was 25. Nicely done. All right, number 8. We've been asked to find X and Y. X is right over here, and Y is right down here. We have two similar triangles. They're nested inside each other. This is, you guys remember the lake problem, find the distance across the lake that we did several days ago? This is very much like that problem. We've created similar triangles by putting one inside the other. It says triangle GHL has been dilated about the point G to create triangle GJK. Find the scale factor and the values of X and Y. So GHL is my original. And GJK is my new. So GJK, this one right here is the new one. All right, so let's do scale factor first. Scale factor is equal to new divided by original. I need to pick out a pair of corresponding sides. What's a pair of sides that would be corresponding between these two triangles? JK, this side right here, that's 10, and HL, this side right over here, that is 30. So new goes on top, 10 goes on top, original goes on bottom, so 30 goes on bottom. Can I reduce this down at all? What goes into both? 10 goes into both. So what's my scale factor? 1/3. I'm going to leave that written as the fraction because when I go to find these missing sides, I don't want to use a rounded decimal. So when I'm finding or when I'm using the scale factor to find other things, if it doesn't come out to be a nice pretty number like 2.5, 2.5 is a nice pretty number because it stops on my calculator. If it's not a nice pretty number like that, I want it in its fraction form so that I get an exact answer when I go to find my missing sides. All right. So we need to find x and we need to find y. You guys okay if we find x first? So scale factor equals new over original. I'm going to leave my scale factor written as 1/3. So 1/3 equals, go look at where x is. What side would correspond to x? JG, this side right here, which is 6. Is 6 part of the new or the original triangle? New, so it goes on top. The original triangle measurement would be the x. So now we're going to multiply by our denominator because we have these fractions. So I multiply both sides by x. X's cancel out over on the right. On the left, when I take something that's not a fraction and I multiply it to something that is a fraction, it only multiplies to my numerator. So that would give me x over 3 on the left and 6 on the right. I still have a fraction though. What operation gets rid of fractions? Multiplication. What part of the fraction do you always multiply by? By the denominator. So what are we going to multiply by here? We're going to multiply by 3. 3's cancel out on the left, leaving me just x. And I get x equals what? X equals 18. Nicely done. All right. One more so that we can find y. Scale factor equals new over original. I need a little bit more room for that. And we know our scale factor is 1/3. Is y part of the new triangle or the original triangle? It's part of the new, so it goes up on top. What should go on the bottom of my fraction? 24. I want y all by itself. Y is part of a fraction. We use what operation to get rid of fractions? Multiplication. What part of the fraction do we multiply by? The denominator. So we're going to multiply by 24. If you do it to one side, have to do it to the other side. So my 24's cancel out on the right. The 24 over here on the left only multiplies to my numerator of 1. So that would give me 24 over 3 equals y. And now I'm going to divide 24 by 3 on my calculator. 8. So y is 8. Nicely done. Let's scoot on to number 9. In the diagram, WXYZ is similar to PQRS. Find the value of y. Do you remember when we did our proportion of sides? yesterday when we had our similarity statement and we had to write out all those fractions that were equal? We're going to use that idea right here. So I'm going to look at my similarity statement. First thing I'm going to do is I'm going to find, it says find the value of y, so I'm going to go find y. Where is y? It's on the first trapezoid. Where on the first trapezoid? On the bottom, right here. It's side zy, right? Well, zy, when I look at my similarity statement, is the last two letters here. So what would it have to correspond to on the other trapezoid? RS. Last two letters, last two letters. So these two sides will make a fraction together. So I have 5y minus 2 over 6. There's one of my proportions. That is equal to, since I know they're similar, I know it has to be equal. I have this side right here, WZ. WZ is the first and last letter here. What would that have to correspond to on the other trapezoid? PS, right here. First and last letter. Which one should go on top, the 16 or the 12? 16, because these two have to come from the same figure. So I have 16 over 12. So far, so good? Y is right here, and it's part of a fraction. I want to get rid of that fraction. What operation gets rid of fractions for me? Multiplication. What are we going to multiply by then? Multiply by 6, whatever's on the bottom of the fraction. If you do it to one side, got to do it to the other side. All right, so the 6's cancel out on the left, which leaves me with just 5y minus 2 over on the left. Does this 6 multiply to both the top and the bottom? No, it only multiplies to what? Just the top. So I do 16 times 6, 96, over 12. After I do that multiplication, I see if I can divide this and get a nice pretty number. What is 96 divided by 12? 8. So 5y minus 2 is equal to 8. Can you guys help me figure out where to go from here? What are we going to do? Add 2 to both sides. So that would give me 5y equals, not 98, we did 96 divided by 12. 10. Yes, 5y equals 10. Then we divide both sides by 5, and y has to be 2. Fantastic. Absolutely fantastic. Yes. When you see a similarity statement and it's asking you to find a variable, first thing you do is you go find where the variable is and you look at what that side is called. Then you go back and look at your similarity statement so that you can find the corresponding side to it on the other one and make a fraction out of those two first. And then you find another pair of corresponding sides that you can make a fraction out of. Yep. You guys want to try something like that again? All right, let's go look at number 10. It says, in the diagram, triangle JLM is similar to triangle QST. Find the value of x, round to the nearest hundredth if necessary. So we're supposed to find x. Where is x? First triangle on which side? LM, right here on side LM. Well, when I look at my similarity statement, LM is the last two letters. So what would that have to correspond to on the other triangle? ST. So I'm going to make a fraction out of LM and ST. So I would have 6x minus 3 over 3 is equal to, now I have to find another pair of corresponding sides. I only have one more side on this first triangle, just this one right here. JM. Yes. JM is the first and last letter. So that would have to correspond to the first and last letter here, which is QT. QT would be this side right here. So what will my fraction be? 4 over 2, yes. Now, normally I don't do this at this point, but I know 4 over 2 in my head. What is 4 divided by 2? 2. So since I know that one, it's so easy, I didn't even have to pull my calculator out. I can just write that down. I can simplify that. What should I do next? Multiply both sides by 3, yes, because that's our denominator. All right, so that gives me 6x minus 3 equals what? Equals 6. Now what do I do? Add 3, yep, on both sides, absolutely correct. And I get 6x equals 9. And now what? Divide both sides by 6. So x equals 9 over 6. That's a fraction that I can simplify, or I can divide it. Let's try to simplify it first. What goes into both 9 and 6? 3 goes into both, so I can divide them both by 3. What is 9 divided by 3? 3. 6 divided by 3? So x equals 3 over 2. Or you could pop that into your calculator and use the decimal. 1.5. Does that process make a little bit of sense now? All right. Go and find the variable that you're supposed to be looking for first. Look at your similarity statement so you can find the corresponding side so you can write your first fraction. And then go, using the similarity statement, find another pair of corresponding sides. We've got 2 problems left to finish up, and that'll finish us out for the day. Yes. You had a question? Oh, yes. So number 11. Given the following polygons are similar, find the value of x and or y. So on part A, do we have both an x and a y? On part A. No, there's 2 x's. We do not have x and y. We have 2 x's. We have 1 x here in 3x minus 7. And then we have another x right here on side zy, x plus 1. Do you guys see those 2? I have to pick one of them to start with so that I can make a fraction. Since they both have x's, it doesn't matter which one I pick to start with. Do you guys want to do the x plus 1 or the 3x minus 7 first? 3x minus 7 sounds good. All right, so 3x minus 7 is on side ZW. Well, here's ZW in my similarity statement. What would that have to correspond to on the other quadrilateral? RS, middle 2 letters, middle 2 letters. So let's go find RS. Here's RS. It's my side that's 12. So I'm going to make a fraction out of that. We're going to have 3x minus 7 over 12. And that is equal to, and now I need the other one, zy. Zy is the last 2 letters. What would that correspond to on the other one? ST. Last two letters. So here's ST. So my other fraction is going to be x plus 1 over 9. So far, so good? I got two fractions, and they both have variables with them. I'm going to have to get rid of both of them, but I can only do one at a time. With math, we can do a whole bunch of stuff, but we can only do one thing at a time. So we have to get rid of one of these denominators first. Which denominator do you guys want to get rid of first? The 12? Sounds good. So how do I get rid of a denominator? Multiply. Yes, multiplication. So we're going to multiply both sides by 12. Cancels out here over on the left. So on the left, the only thing I have remaining is 3x minus 7 is equal to. The 12 only multiplies to what part of this fraction? Just the top, just the numerator. But what's the thing about my numerator? How many parts does it have? 2. I have to multiply the 12 to both parts. It has to distribute. So I would have 12x plus 12 over 9. Now we can get rid of our other denominator. How do I get rid of that denominator? Same way, multiply. Multiply by 9, put parentheses around things over here, and multiply by 9. Cancels out my denominator on the right. On the left, I have 9 being multiplied to everything on this side. And once again, there's 2 parts, so I have to distribute that 9. So I have to do 9 times 3x. What is 9 times 3x? 27x minus 9 times 7. 63. So 27x minus 63 equals 12x plus 12. Then I'm going to get my x's to the same side, so I'm going to minus 12x from both sides. Cancels out my 12x over there on the right. What is 27 minus 12? So I have 15x minus 63 equals 12. Then I'm going to add 63 to both sides. What is 12 plus 63? 75. So 15x equals 75. Then we divide both sides by 15 to get our final answer. What is 75 divided by 15? 5. So x is 5. One last problem and we'll call it a day. Says that triangle JKL is similar to triangle WYZ. We need to find x. Is there a y here? Yes, x is right here. It's this angle. And y is down here. It's this angle. So now, do I care about matching up corresponding sides? No, I want to match up corresponding angles because x and y are in my angles. So what angle corresponds to J? W, yes. First letter, first letter. J and W are corresponding. So J and W. So that means angle J is congruent to angle W. What can we do with things that are congruent? Set them equal. The measurement of angle J is equal to the measurement of angle W. So 4x minus 13 is equal to what? 71. Yes. Now I'm going to add 13 to both sides. What is 71 plus 13? 84. 4x equals 84. Then we divide both sides by 4. What is 84 divided by 4? 21. So x is 21. We didn't even have to do any fractions on that one. That was kind of nice. All right, we still need to find y. Y is part of angle K. Angle K is right here in the middle. What would that correspond to?
Y.
Angle Y right here. So K and Y. I have a problem. I don't know how big that angle is. I know that the measure of angle K is congruent to angle Y. So the measure of angle K is equal to the measure of angle Y. This is just Y degrees, but I don't know how big this is. Do I have the ability to find that though? Yes, because we know the three angles in a triangle add up to how much? Add up to 180. So let's add these two angles together and minus it from 180. 44 plus 77 would give us what? Or 71, thank you. Thank you for fixing my error there. 44 and 71 adds up to what? 115. And so then we do 180 minus 115. 65 degrees is this angle right here. So how big is y? 65. Y equals 65. Nicely done. All right. Homework assignment that you guys received yesterday in class is due on Monday. We've gone through all of the notes that you need to be able to complete that. And then Monday we will start in on our next section of notes.